Hello student, in this video we will learn T flip-flop and D flip-flop in detail. We know the definition of flip-flop, that is, it is a clock-driven sequential circuit which can store 1-bit data. That means one flip-flop store 1-bit data. We already discussed the two different types of the flip-flop, that is SR flip-flop and JK flip-flop in the previous video. Now let us study what is D flip-flop and T flip-flop in detail. The learning outcomes of these videos are: the students will be able to understand what is T flip-flop, its symbolic representation, truth table and application of T flip-flop. Similarly, the student will be able to understand what is D flip-flop, its symbolic representation, truth table and application of T flip-flop. Now let us see what is T flip-flop. The T flip-flop is a single input version of the JK flip-flop. The T flip-flop is obtained from the JK type if both the inputs are tied together. T flip-flop is also known as a toggle flip-flop. To avoid the occurrence of intermediate state in the SR flip-flop, we should provide only one input to the flip-flop called as a trigger input or the toggle input. Then the flip-flop acts as a toggle switch. Toggling means changing the next state output to the complement of present state output. Now see the symbolic representation of the T flip-flop. So this is a JK flip-flop where J and K are the two input which are tied together and the new input that is called as a T. And this is a clock signal and there are the two output, that is Q and Q bar, which will be complementary to each other. Now the same simplified representation is nothing but, instead of showing this J and K connection, here directly, as it is having only one input, we can call this as a T as an input. This is a clock and Q bar, these are the two output. Now look at the actual diagram of the T flip-flop, which is having 4 NAND gates. So if you observe this diagram, it is nothing but a JK flip-flop diagram only. Only slight change, that is J and K are connected together and this is a new input which is called as a T. Now see what will be the truth table for the T flip-flop. We know the truth table of the JK flip-flop. This is a truth table for the JK flip-flop. As T flip-flop is simplified version of the JK flip-flop, that means J and K are connected together, that means both will be the same. That is nothing but T input. So from this table we have to consider such condition where J and K are same. That means this first condition where J and K are 0 and last, that is fourth condition when J and K are 1. So let us recall this condition. When J and K both are 0, there will not be any change in the output. That is no change condition. Similarly, when J and K are both are high, that is 1, the output will toggle. So this is nothing but T flip-flop. So the simplified truth table will be shown here. This is a T as an input, the clock, and the Q and Q bar are the output. So as only one input is there, so possible combinations will be only two combinations, that is either it will be 0 or 1. That means when T equal to 0 and when the clock will be there, the output will be, see this table, when J and K 0, there is no change condition. So it will be in hold condition or there will not be any change. Output will be remain same as the previous condition. So next condition, that is when T equal to 1, when the clock will be there, the output will be toggle. So we know the meaning of toggling means, if the previous output is 0, it will be 1, and if the previous output will be 1, it will be 0. So simply if you give T equal to 0, so in the output there is no change, and if you give T equal to 1, the output will toggle. So T flip-flop is a simplified version of the JK flip-flop. Now see the applications of T flip-flop. It is used in the frequency division circuit, or that is in the counter circuit, and second application, that is in 2-bit parallel load register. Now let us study D flip-flop in detail. It acts as a simple memory or the latch. The previous value stored, that is Qn, has no effect unlike other flip-flop. It therefore acts as a simple memory or the latch. A shift register consists of several D flip-flop, one for each bit to be. D flip-flop is also called as a delay or data flip-flop. See, this is a symbolic representation of the D flip-flop. The first diagram is for the positive edge trigger clock, whereas the second diagram, it is for negative edge trigger clock. So if you look at this diagram, there is one input, that is D, whereas the two output, that is Q and Q bar, which are complementary to each other. Now look at the actual diagram of the D flip-flop. If you observe the symbol in the JK flip-flop, the J and K are connected by one NOT gate. So the new input, that is called as a D. So D flip-flop is also a simplified version of the JK flip-flop. Now in actual diagram, this diagram is nothing but our JK flip-flop, in which we have connected one NOT gate between the two input, that is J and K, and the new input, that is D. And there are the two output, that is Q and Q bar. Now we will see the truth table for the D flip-flop. As it is a simplified version of the JK flip-flop, let us refer the JK truth table, in which the J and K should not be same. That means the second and third condition, when J and K are inverted. Now in this, when the J is 0, that means D equal to 0, the output is also 0. That means if you give D equal to 0, the output Q is also 0. Now if you give D equal to 1, that means J equal to 1, the output, that is Q, is again 1. So when D will be 1, the output Q is also 1. So simplified table for the D flip-flop is, when the clock is not there, there will not be change. But when the clock is there and D is 0, that time output is also 0. And when D is 1, that time output is also 1. That means whatever the data we are giving, let us consider 1, we are getting again the same output, but with some delay. That's why this D flip-flop is called as a delay flip-flop. The applications of D flip-flop are in data transfer, counter, shift register, frequency divider circuit. Now as we have completed all the different types of the flip-flop, let us recall the truth table now. So as we have seen, the different flip-flop, that is SR, D, T, can be designed using JK flip-flop. This JK flip-flop is called as an inversal flip-flop. So if you refer the JK flip-flop table, the middle two conditions, that is nothing but a truth table for D flip-flop, where J and K are not same. Whereas if you consider the first and last condition, where J and K are same, that means it is T. This first and last condition is nothing but T flip-flop. Whereas if you consider all these four combination except the last condition, where the output for the SR flip-flop, if S and R both are 1, the output is invalid for SR flip-flop. Thus we studied the different types of flip-flop and its applications.